Hey everyone, today we're going to be looking at the different types of compounds. Don't forget that along with the lecture slides, you have a graphic organizer which follows along quite nicely. So with that being said, the reason that we need to be able to recognize different types of compounds is because depending on the type of compound that we have, we can look at the different types of properties that might exist for that compound. And something that's going to come directly after this is we're going to be looking at how to name the different types of compounds. So without further ado, let's go ahead and jump into it. So there are three main types of compounds. We have molecules. Molecules are going to be covalent compounds. We have ionic compounds. And we have acids, and acids are a subclass of molecules, but it's important to kind of state these right now since they have different nomenclature rules, which we're going to look at in a little bit. So let's go ahead and get started here. Molecules, here's a couple of examples, a couple of pictures of molecules listed down below. And notice that they all have a certain number of bonds that exist between them, and they all have specific shapes that exist in space. These are the smallest unit of a covalent compound. We have two or more elements, either identical or not, combined in specific shapes. Now, if this is a covalent compound, if this is a covalent molecule, generally speaking, the substances that are taking and participating in these molecules are non-metals. So two or more things that exist from the right-hand side of the periodic table. So these, once again, between two or more non-metals. So over on the left-hand side here, we have an example of carbon dioxide. Carbon's in the middle and the two oxygens are on the outside. The green octagon-looking molecule is going to be sulfur. Elemental sulfur is S8. So it's literally 8 sulfur atoms bonded in a circle here. This blue and purple molecule is going to be iodine pentachloride, so iodine's in the middle, and it's bonded to 5 chlorine atoms. And then over on the right-hand side is our favorite molecule, water, H2O. Now, a subclass of molecules is going to be the diatomic molecules, and if you don't have these memorized already, you really should. You really should spend some time making sure you understand what the diatomics are. Certain elements exist as diatomics rather than their single atoms, and this is just when they're acting in space, when they're in nature. And once again, this allows for them to be more stable. Now, a mnemonic which helps us memorize this is Brinkelhoff, where each capitalized letter indicates a new element that will generally exist in its diatomic state. For example, if I were to look at chlorine gas here is generally speaking Cl2, not just Cl. And it's quite literally just two chlorine atoms bonded together. And they can exist with other chlorine atoms here. But notice that they all form this chemical bond that exists between them. They are never going to be a single chlorine atom floating around, rather on planet Earth. We could do the same thing. Oxygen gas, I think, is probably one of the more obvious examples. O2, this is the element that we go ahead and breathe. And it is quite literally two oxygen atoms chemically bonded to each other. Now, atomic oxygen, where it's just a single oxygen atom, does exist higher up in our atmosphere. We also have ozone, which would be O3, where it's 3 oxygen atoms bonded together. And remember, as far as these molecules, so this is a molecule of the oxygen atom, this is a molecule of ozone, and this is a molecule of diatomic oxygen, O2. All of these are allotropes of each other. They are the same element, but in different forms. And once again, all of these examples of molecules, remember, are existing between two or more nonmetals. Now, ionic compounds are slightly different. They are always going to exist between a metal and a nonmetal. They are composed specifically of oppositely charged ions bonded to themselves over and over and over again. And usually they create these ginormous complexes called crystal lattices. And these crystal lattices have the positive, negative, positive, negative. So when we're looking at the formula for these, so for a good example, this would be like sodium chloride. It's just NaCl, but as you can see, these complexes don't have just one Na and one Cl. So what's important to understand about the ionic compound and the ionic formula specifically is that the formula represents a ratio of ions that exist within the crystal lattice. And yeah, last but not least, we have acids. Acids are quite easy to spot. Generally speaking, these are going to be substances that begin with H. The formula will go ahead and begin with H. And acids specifically are substances that increase the hydrogen ion concentration in solution. Some examples of this would be HCl, hydrochloric acid, uh, H2SO4, which would be sulfuric acid, or H3PO4, which would be phosphoric acid. Once again, notice that all of these examples have the hydrogen in the front. And once again, notice that all of these are composed of non-metals. So technically they are a subclass of the molecules, but it's more important to identify them as acids because they start with the hydrogen. All right, thanks so much. Let me know if you guys have any questions. Just shoot me an email.